Hello, welcome back to my channel. So this is part 2 of mole conversions. So in the last video I talked about one-step conversions from mole to mass, mass to mole, mole to particle, particle to mole, so just one simple step. But today I'll be going over 2 steps. So you gotta convert, basically go through 2 steps in the train tracks to get to your final answer. So basically we're going to do both of these in our calculation. So as a reminder, we have our mole also equals the molar mass of whatever element or compound that we're working with, and then also 1 mole equals this standard number, the Avogadro number 6.02 times 10 to the power 23. And whether it's particles, atoms, molecules, they're the same. They're always associated with the Avogadro number. So we're going to go ahead and just get started with our first example. How many grams are in 5.23 times 10 to the power 17 atoms of H2O? Okay, so whenever there's grams involved in a problem, I would just go ahead and find the molar mass just to get that out of the way, have that to the side, so that way you can just plug it into our train tracks. Alright, so we're going to start with that first. H2O again, as a reminder, we have our hydrogen from our periodic table is 1.008, and there's 2 of them, so times 2 is 2.016, and then our oxygen is 15.999, and there's only 1, so that's all we need, and then we add them both together, so our final molar mass for water is 18.015 grams, and we're going to put that in our calculations in a little bit. Now we're going to start with our train tracks. We are starting with our given 5.23 times 10 to the power of 17 atoms H2O. Again, always include units, because units tell us what to do next. So we want to cancel out the atoms so that way we get to grams. So I'm going to pull those units down here. And any time we have atoms, it is associated with our Avogadro number, so 6.02 times 10 to the power 23. And according to our ratio here, Avogadro number always equals to 1 mole. And we put that on top. Because there's no, according to our equations here, our ratios here, there's no direct conversion from grams to atoms. So we have to go through mole first, because there is a direct conversion from mole to gram. So we have to get to mole in order to get to gram. Alright, so that is 1 mole, and that cancels out our atoms. And now we need to get to our second step here to make it 2-step. I have mole of H2O. We put that down here, and it's 1 mole, and that equals to our molar mass, which we just found right here, 18.015 grams of H2O. And that is exactly what we want. Now we solve. Now there's numbers top and bottom. I know in the last video, in the bottom there's always just 1, so we just multiply, but now we have to multiply and divide. So just to make things easier, just to show you how we solve for this, how we punch it into the calculator, is 5.23, we multiply across, and then we divide by the bottom. So 5.23 times 10 to the power 17 times 18.015. I should put this in parentheses to make this look easier. And then we divide it by the bottom, which is our Avogadro number, and then we solve. And I also recommend doing it, putting into the calculator step by step. Don't punch it in all at once, because sometimes calculators, depending on the calculator, sometimes calculators don't know how to do PEMDAS correctly. So I'll just go ahead and just do the multiplication first. Times 18.015. I got a number. Alright, so again, I'm just going to show every single step. I'm going to do in 3 decimal places. And then we're going to divide that by our 6.02. So we get this number divided by 6.02 to the power of 23. So over here, I'm going to change it to scientific notation. And this is our number here, our final answer. So that'll be 1.565 times 10 to the power of -5. And it'll be grams of H2O. So this is a very, 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 very small amount of grams of water, because that's actually not a lot of atoms. Alright. Awesome. So we'll do the other way around. See the difference. How many molecules are in 15.7 grams of CO2? So okay, again, if there's any grams anywhere in the question, just right away find the molar mass, so that way you have it ready to go for your calculation. So I would pause this video, actually try to find the molar mass by yourself, and then unpause to check your work on your molar mass. So you should get 44.009 as your molar mass for CO2. So now we're going to go ahead and get started with our train tracks. We are starting with 15.7 grams CO2. So this is what I mean by opposite, okay? You're not going to always start off with Avogadro number. Sometimes you have to start with mass, depending on what the question is asking. So again, which is why units are very important. I'm starting with grams of CO2. Put that down here. And since it's grams of CO2, we just found that here. So I'm going to put that 44.009. And according to our ratio here, that is 1 mole. Again, we're going through mole in order to get to our molecules. So again, notice that I put molecules. Do not confuse yourself between molecules and mole. It kind of looks similar, like it's short for, you know, mole or whatever. Molecules is very different. Molecules is associated with the Avogadro number here. Alright, so 1 mole of CO2. And we're going to our second step. We're going to pull our mole of CO2 down here. And that is 1 mole. And that equals our 6.02 times 10 to the power 23 molecules CO2. And I would not shorten, like abbreviate molecules, because if you abbreviate molecules, it confuses yourself with mole. So don't be lazy, write the full word. And that's it. You are pretty much stopped at what you want. You want molecules. And now you solve. So 15.7 times 1 times 6.02 to the power 23 divided by 44.009. I'm just going to write that out. I'm not going to write the 1 because it doesn't really do anything. And now we solve. There we go. So we got our answer as 2.148 times 10 to the power 23 molecules of CO2. And that is it. Alright, so now I'm going to give you one example. You're going to try this by yourself. And then you're going to pause the video, work it out, and then unpause to check your work. Alright, so let's say I give you how many particles are in 16.72 grams of NH3. So do the same steps that you have done before, the last two problems. So you have to know which one you start with and like what goes top and bottom. Again, pause the video and try it on your own. Alright, so this should be your final answer, 5.91 times 10 to the power of 23. So again, you start with grams, you start with your molar mass, and then when you convert to moles, you put your Avogadro number on top for particles. When I calculate that, multiply the top, divide by the bottom, this is what you should be getting. Alright, so this is pretty much it for our two-step mole conversions. I hope this helps, and thank you for watching.